Welcome back to the channel. We're going to study for NVG check ride together. In this video, we'll go over anatomy and physiology of the eye, day versus night blind spot, types of vision, visual deficiencies, and dark adaptation. Anatomy and physiology of the eye. If you look at the top view here, you have the cornea, outer protective layer, the iris, the part that contracts and expands to let light through your pupil, your lens behind your pupil, and your optic disc down here, no rods, no cones, and you have your optic nerve down here. So I'm going to read this paragraph to you and we'll talk about it. When light from an object enters the eye, it passes through the cornea. The cornea is a circular, transparent protective tissue that projects forward and protects the eye. Once light travels through the cornea, it enters a pupil. The pupil is an opening, black center portion in the center of the iris. The pupil allows light to enter the eye to stimulate the retina. The iris is a round, pigmented colored membrane of the eye surrounding the pupil. So if you have green eyes, the iris is the green part. The iris adjusts the size of the pupil by using its ciliary muscles, which are attached to the pupil. The iris adjusts the size of the pupil to regulate the amount of light entering the eye. So if you have a lot of light coming in, it gets smaller. If you have a little bit of light coming in, it gets bigger. All right, the lens is a transparent biconvex membrane located behind the pupil. So right here, behind the pupil, you have your iris, you have your lens. The lens then refracts the light upon the retina, the posterior or rear portion of the eye. The retina is a complex structured membrane consisting of 10 layers called the Jacob's membrane. The retina contains many tiny photoreceptor cells called rods and cones. Once light stimulates the retina, it produces a chemical change within the photoreceptor cells. When the chemical change occurs, nerve impulses are stimulated and transmitted to the brain via the optic nerve. The brain deciphers the impulse and creates a mental image that interprets what the individual is viewing. So, just a quick overview here. Light comes to your cornea, the protective part of your eyeball, through your pupil, which is expanded and contracted by the iris, to your lens, which refracts and reflects light to your optic nerve through your optic disc. Depending on if it's light or dark outside, your pupil will get smaller or bigger with your iris. Day versus night vision. Night blind spot. Night blind spot occurs when the fovea becomes inactive under darkness or with low-level illumination. Central vision becomes less effective and a night blind spot develops. 5 to 10 degrees wide. This is very important to remember, 5 to 10 degrees wide. This results from a concentration of cones in the fovea centralis and parafovea, the area immediately surrounding the fovea of the retina. The night blind spot should not be confused with the physiological blind spot, the so-called day blind spot, caused by the optic disc. Because of the night blind spot, larger and larger objects will be missed as distances increase. To see things clearly at night, the individual must use off-center vision and proper scanning techniques. Utilize the off-center vision technique to compensate. So, night blind spot, what it's getting at, 5 to 10 degrees wide, remember that part, and then larger and larger objects are easily missed at distances. So, if you think about a tower that you're standing right next to looks huge. A tower that you're looking at from 10 miles away looks small. So just remember, big objects can be missed at night whenever they're farther away from you. Day or physiological blind spot. The physiological day blind spot is present all the time, not only during the day. The blind spot results from the position of the optic disc on the retina. The optic disc has no light-sensitive receptors. The physiological blind spot covers an area of approximately 5.5 to 7.5 degrees and is located about 15 degrees from the fovea. Compensated by binocular vision, each eye compensates for a blind spot in the optic disc of the opposite eye. So, a takeaway from day versus night. Night blind spot is 5 to 10 degrees. Day blind spot is 5.5 to 7.5 degrees. Day blind spot is compensated by each individual eye or each other eye. So this eye covered, you have a blind spot. This eye covered, you have a blind spot. Both the eyes compensate for each other. Types of vision. The 3 types of vision are daytime vision, photopic, dawn and dusk vision, mesopic, and nighttime vision, scotopic. Photopic vision is used during daylight or when high level of artificial illumination exists. The cones concentrated in the fovea centralis of the eye are primarily responsible for the vision in bright light. Because of the high light level, rhodopsin is bleached out and rod cells become less effective. Sharp image interpretation and color vision are characteristics of photopic vision. So photopic vision, used in high level of light, you look straight at stuff. You don't have to use a scanning technique. Color perception is good. You use cones. Best visual acuity is 20/20, and the blind spot is just the day blind spot, which is 5.5 to 7.5 degrees. Mesopic vision is used at dawn, at dusk, and during full moonlight. Vision is achieved by a combination of rod and cones. Visual acuity steadily decreases as available light decreases. Color perception changes because the cones become less effective. As cone sensitivity decreases, crew members should use off-centered vision and proper scanning techniques to detect objects during low light levels. So mesopic vision review, it's used in medium to low light level. You use both scanning techniques as well as central. You can see some color, but it's degraded color. You use rod and cones. Your best visual acuity varies in its night blind spot as well as day blind spot, so both blind spots. Scotopic vision. Scotopic vision is experienced under low light levels. Cones become ineffective, resulting in poor resolution of detail. Visual acuity decreases to 2200 or less. This enables a person to see only objects the size of or larger than the big E on acuity testing charts from 20 feet away. A person must stand at 20 feet to see what they normally can see at 200 feet under daylight conditions. Also, color perception is lost. A night blind spot in the central field of view appears at low light levels. The night blind spot occurs when cone cell sensitivity is lost. So nighttime review or scotopic vision review. Scotopic vision, nighttime vision, is in low light levels. Viewing techniques, you need to use scanning because you have your night blind spot 5 to 10 degrees wide that you can't see. Color perception is lost. Receptor uses, so you only use your rods because the cones become ineffective. Best visual acuity is 2200, and your blind spot is day as well as the night blind spot. Deficiencies. Several visual problems or conditions can affect night vision. These include presbyopia, night myopia, myopia, hyperopia, or stigmatism. I'll give you the lowdown here. So, presbyopia, this condition is a part of a normal aging process which causes the lens of the eye to harden. So anyone over 30, any old people like me. Presbyopia, old people. Night myopia. Myopic individuals do not see distant objects clearly. Only nearby objects are in focus for them. Because of this, slightly nearsighted myopic individuals will experience visual difficulty at night when viewing blue-green light that could cause blurred vision. Also, image sharpness decreases and pupil diameter increases. So, if you're nearsighted, that will affect you, the blue-green light. Myopia. When a myopic person views an image at a distance, the actual focal point of the eye is in front of the retina plane. Cause blurred vision. Thus, distant objects are not seen clearly. Only nearby objects are in focus. This problem is referred to as nearsightedness. So myopia is nearsightedness. Hyperopia, what's the opposite of nearsightedness? I'll give you a chance to answer. Okay, so myopia, error in refraction. The lens of the eye does not focus an image directly on the retina. When an individual with hyperopia views a near image, the actual focal point of the eye is behind the retina wall, causing blurred vision. The problem is referred to as farsightedness. So just to recap here, you have presbyopia, you're old. Night myopia, you're slightly nearsightedness, that it messes with your lights, it messes with your eyeballs at night, makes stuff harder to see at night because you're nearsightedness. Myopia, you're nearsightedness. Hyperopia, you have farsightedness. All right, and then astigmatism. Most people refer to astigmatism. Astigmatism is an unequal curvature of the retina that may cause an out-of-focus condition. For example, an astigmatic person focuses on power poles vertical and wires horizontal will be out of focus in most cases. So you're looking at stuff on the same plane, but since it's at the same distance, but since it's on a different plane, you can't see it as well. Dark adaptation. Definition. Dark adaptation is a process by which the eyes increase their sensitivity to low levels of illumination. So starting level. The lower the starting level of illumination, the less time is required for adaptation. Each person adapts to darkness in varying degrees and at different rates. Exposure to intense sunlight for 2 to 5 hours decreases visual sensitivity for up to 5 hours. Cumulative effect. The rate of dark adaptation and degree of night vision acuity decrease may persist for several days. Sensitivity. When fully dark adapted, rods become 10,000 times more sensitive than at the start. Alright, so if you get your eyes dilated, through a dilated pupil, total eye sensitivity comes 100,000 times more sensitive. That's why your eyeballs hurt after the eye doctor after you get your eyeballs dilated, because you're getting 1,000 or 100,000 times more sensitive than you would if you were just during the day. Time to dark adapt, 30 to 45 minutes under minimal lighting conditions. Time to readapt after high intensity lighting, several to 45 minutes. That's because everybody does it different. Just a recap here. Everybody's body and physiological ability, probably to do with how healthy you are, your blood flow, just the way that your body is. A way to decrease the time that it takes for your eyes to adapt, like if you're going to go fly nights or whatever, a lot of guys will wear sunglasses. I'm always wearing sunglasses during the day, and it's kind of a habit from this, but also I just like wearing sunglasses. And that is a way, if you're having a night flight coming up and if your aircraft's out underneath lights or whatever, I always have sunglasses on to pre-flight or do whatever. So thanks for watching the video. This was a boring, very dry video, but if you need to know any of this for your check ride, hopefully it helped, or maybe you just learned something. I seriously doubt anybody's going to watch this, but it did help me to study this portion for my flight. So thank you for watching. I'll see you in the next one. Bye.